All right, in this video I'm going to be walking through the entire SAT practice number 5. So make sure that if you've downloaded this, you have the correct version, but this is number 5. And we are starting with the no calculator. So here we go, let's get after it. So number 1, which of the following is an equation of a line in the XY plane above? Couple key features. First thing I notice is the y-intercept, where it crosses the y-axis. Crosses at +1. So in general, your line should have a form of y equals mx plus b. And this b, this back number here, represents the y-intercept. So looking at my choices right now, it pretty much is going to be D. The other thing I want to notice is the slope. Since this line is increasing from left to right, it's positive. Decreasing would be negative. Always viewing it from left to right. Well, this line is increasing up 1 over 1. So it also has a slope of 1, which m represents the slope. So correct answer here is D. I just want to point out a couple of the other lines just to show you what they are. X equals 1 is a vertical line right here. So this is the line x equals 1. So that's that choice. I'll do the green line here. Y equals 1. Well, when you're missing an x value, you basically just cross the y-axis at 1. So those are all going to be horizontal lines. And then lastly, the line y equals x is the line that, it looks a lot like this line, same slope, but it crosses through the origin. So it would have been parallel to this guy, kind of running like that. But the correct answer here, the line that we were looking for, was the blue line. There you go. Number 2, circle above with center 0, or the letter O, has a circumference. So remember here, vocab word, circumference is the distance around the circle. Has a circumference of 36. So we know that all the way around here, if we could straighten this line out, the distance all the way around there is 36. What is the length of minor arc AC? Minor arc means the short distance to get from point A to point C, which represents right here. Well, since this is the center, and we have 90-degree markers, we basically broke it into quarters. So it is going to be 36 divided by 4, because it's a quarter of the way around the circle, which would be 9. So correct answer there is A. Moving right along, come down here to number 3. What are the solutions of the quadratic equation? So quadratic's pretty big topic, often covered here in the no calculator version. First thing I notice is all of these terms are divisible by 4. So I'm going to divide the entire equation by 4, and that's going to give me x squared minus 2x minus 3 equals 0. Whenever you want to solve a quadratic, you got to get everything equal to 0, which it's already kind of set up that way. And now we need to factor. We need to kind of play the game, and it's really easy as long as there's no number in front of x squared. Basically, we need to find two numbers that can multiply to make -3. So let's just look at that. How can I make a -3? Well, I could be +1 times a -3, or I could be -1 times a +3. These are my factors. But then the second part is I need to be able to add to make -2. So the right combination that adds to make -2 are right here. So we're going to have x plus 1, x minus 3 equals 0. And now we're going to use what's called the zero product property. Kind of get this out of our way for a second. Basically, if I have something times something equals 0, one of those two have to be 0. So we just solved two cases. When is x plus 1 equal to 0? Well, I minus 1 from both sides. I get -1. So there's one answer. And then when is this guy equal to 0? Add 3 to both sides. And so I get my answers, 3 and -1, which is, correct answer right there is B. All right, moving on down. Let's go down to number 4. Which of the following is an example of a function whose graph in the xy plane has no x-intercepts? All right, so I want no x-intercepts. So remember, the x-axis is here. So basically, I'm not allowed to cross the x-axis. So would it be a linear function whose rate of change is not 0? Well, no, because that's just going to be a line. And a line, I don't care which direction you're going, it's at some point going to cross the x-axis, unless it had a 0 slope, but they kind of ruled that out. A quadratic with real zeros. Real zeros mean that you actually hit or you touch the x-axis. So zeros are what points are down here. They're solutions, they're roots, a lot of different names for zeros. Now this one right here is pretty interesting because a quadratic with no real zeros, so that means it has imaginary roots. And that basically is, a quadratic is like a parabola. So we're looking at something like this or something like this. Neither of those cross the x-axis, so they're going to have no real zeros. Correct answer there is C. Moving right along, let's check out number 5. Looks like we have a square root problem here. So let's see if we can solve this. In the equation above, k is a constant. I get a lot of questions from my student what a constant is. A constant is just a number. All right, it's no big deal, just some plain old number. Now, if x equals 9, what is the value of k? So first thing I'm going to do is I'm going to substitute that 9 in. So I have the square root of k plus 2, subtract 9, equals 0. And just like anything, I'm going to kind of focus on getting this expression by itself. So I'm going to add 9 to both sides. And I'm going to end up with the square root of k plus 2 equals positive 9. And me, I kind of do this two different ways. I almost, in my mind, kind of just ignore what's in here. And I just kind of say, hey, the square root of what is 9? And I happen to know that the square root of 81 is 9. So then I just kind of look in this expression and I'm like, well, how can I get what's inside there to equal 81? So I subtract 2 from both sides and I get an answer of 79. Now, if you want to get a little bit more formal than that, I'm sure some traditional teachers wouldn't like how I just did that. They'd have a problem. So technically what I'm supposed to do is I'm supposed to, once I get it down to here, to get rid of this square root, I need to square both sides. So I'm going to square the left side and I'm going to square the right side. Basically, squaring and square rooting are inverses, so they kind of cancel each other out and disappear. And then I'm back to kind of where I was earlier. I minus 2 from both sides, and I get 79. Now, you also could just plug answers in, and they know that. I find a lot of times when you can just plug answers in, I like to start with the bottom number because typically they make you work for it and go through all the choices. All right, number 6. Go up here, scroll up to number 6. Which of the following is equivalent to the sum of expressions? So this is when I kind of break down categories on the SAT. This falls under the manipulate expressions. We're not solving. We're just trying to write an equivalent one. So sum here, you need to know what that means. That means to add. So I need to take a squared minus 1 and add to that a plus 1. And now it's just about combining like terms. You know, I have an a squared, which there's only one of those. I have a positive a, there's only one of those. And then I have this minus 1 plus 1, which disappears, which pretty much matches up with question A. All right, so let's scroll down, check out number 7. 7, we got a story problem here. It looks to me like we have a system of equations, and we just need to construct a model. So I call this constructing linear models. But it's a system. So let's kind of sift this out. Jackie has 2 summer jobs. She works as a tutor. So tutor is $12 per hour. What letter are we using there? X is the number of hours she tutors. So we need to kind of keep that straight. X equals tutor, and that was $12 per hour. And then the other piece of the puzzle is she also works as a lifeguard, which is $9.50, and Y is the hours she works as a lifeguard. So Y equals hours as a lifeguard, and she's getting $9.50. So right away, that kind of helps me out a little bit. And I put $12, but it was actually $12.50. hours tutoring. So right away, I know that I have a 1250 multiplied by every hour that I tutor. We're going to add to that. We got 950 times every hour lifeguarding. So let me just kind of peek through and see if I can get rid of anything. It looks like all of the first lines have that part correct. And it says, so looking at these lines, notice the top lines. They all have the 12x, the 95y. But what's different and what distinguishes them is the 220. And so it said here that we can have at least 220 per week. So she needs to make at least, which means we need to be greater than or equal to. So that wipes out, this is less than or equal to. So that wipes this one out. This is less than or equal to. So now we got it down to C or D. And the only thing that distinguishes these two is the symbol for the 20. So let's look at that part. She can work no more than 20 hours. So that means I got to be less than 20 hours. And here's the less than symbol. So correct answer there is C. So a lot of times it comes down to breaking down the problem and seeing what's different between the answers. And sometimes you can kind of just do it in pieces. Oftentimes I find I get the right answer before I even solve the entire problem. All right. Let's move on down here. Let's take a peek at number 8. In air, the speed of sound in meters per second is a linear function, so we know it's going to be a line. We're going to have some sort of starting point, some sort of rate of change. So I look at these numbers, and it's kind of like, you always want to think of a line as like y equals mx plus b. This constant, this standalone piece is the intercept or the starting point. So this thing starts at 331.4. And then how much it's changing is going to be the slope. So this thing is changing by 0.6. So that kind of gives me an idea of what's going on. So this is interpreting a linear model. Interpreting means you got to say what the numbers mean. So if you visualize this on a graph, this really isn't totally necessary, but I do want to explain it. We have the temperature as a function, or actually, I take that back, redraw this. We have the speed of sound as a function of temperature, all right, S of t. So basically, here, when the temperature is at 0 degrees, and we're talking Celsius here, the speed of sound is 331.4. And then basically, every degree, every time, like if I plug 1 in there, I'm going to add 0.6 to it. So you kind of come up, and we're just slowly creeping up 0.6 more. So now this piece is going to be worth 332 because I added 0.6 to it. If I go 2 more degrees higher, I'm going to add another 0.6 to it. So I'm going to be at 332.6. If you had a calculator, which you can't use here, you could graph it. But what does a 331.4 represent? It's basically the speed of sound at 0 degrees Celsius. The y-intercept is always going to be when your bottom variable is at 0. All right, let's keep on going. Number 9. So, system of equations, but a little bit tougher. You can usually expect, according to my data, and I've went through a lot of tests, I can predict 4 to 5 systems of equations, and only once, if that, will you see one that's not both linear. Like I realized this dude is a quadratic because he has a power of 2. So basically we have some sort of parabola. And then down here, this is linear, so we have a line. So we're going to somehow have some line come through, and basically our solution is going to be where they intersect. So a couple different ways that we could do this. One way that we could do this is we could probably use substitution. I like to use substitution when it's already solved for a letter, like we know what y equals. Y equals x squared. So let's just substitute x squared in for y. So we have 2x squared plus 6 equals 2 times x plus 3. So now I have one equation, one unknown, and I should be able to get the answer here. The other thing I need to pay attention to is they only want x answers bigger than 0. So that probably means there's going to be a positive and a negative, and I only want the positive one. All right, so let's get after this. We have 2x squared plus 6 equals, I'm going to distribute here, 2x plus 6. Whenever you solve a quadratic, you want to get it equal to 0. So I'm going to move these two terms to the other side by using subtraction. So I'm going to have 2x squared minus 2x. And this minus 6 and this minus 6 are going to kind of squash each other. And I'm going to end up with 0 there. I didn't really show the other minus 2x, but it's there. And now to factor this, I'm going to pull out the greatest common factor, which I can pull a 2 out of both of those, and I can also pull an x out of both of those. It's kind of like reverse distributive property. So now I got to ask myself, 2x times what will give me 2x squared? And then 2x times what will give me negative 2x? And now I can use that zero product property that we used just a couple questions back. So either u equals 0 or u equals 0. So 2x equals 0. Well, that happens here. But they didn't want that. They said x can only be greater than 0, so I don't need this option. But when I solve when is this person equal to 0, it said x equals 1. So what they want you to do, huge mistake here, do not pick A. You did a lot of great work, but the answer is not 1 because look what they actually want. They want to know what's the value of x times y. That's how they trick you. That's how they get good kids to miss problems. So I got to go back and I got to get y. So I'm going to kind of come back up here in the beginning and I'm going to substitute. Now that I know x equals 1, y equals x squared, or y equals 1 times itself. So y actually equals 1. Well, it looks like you would have got lucky here because they want to know the value of x times y, and x times y is basically just 1 times 1. So looks like you could have screwed up and actually got rewarded. Very seldom happens on here, so just pay attention to asking the final question. I like to underline it so I know what I'm doing. All right, moving on to number 10. Number 10, so what do we have here? Looks like we have a couple equations that we need to manipulate. So I kind of put this in the category called manipulating equations because we're not solving anything. We're just repackaging stuff. A squared plus b squared equals z, and ab equals y. Which of the following is equivalent to? So I think if you're telling me what z equals, I should be able to plug it in right here. I should be able to substitute. So I'm going to kind of move over here to the left side. So we have 4 times, this is really our z, but we just replaced it. And then we're going to add to that 8 times, and instead of putting y in there, we now know that y is just ab. So 8ab. So I just kind of stuck that in for y. And now we got to simplify this. So let's do a little bit of distributing here. So we have 4a squared plus 4b squared plus 8ab. And I've done enough of these to know kind of how the layout is. So I'm going to switch these two terms. It's not really critical, but I just kind of have done enough of these multiplying problems that I know kind of how the format looks. And one of these is going to match it. And basically, remember, these squareds just mean you're taking the first thing and you're multiplying it by itself. And really, you only have to do the very first piece because if you notice, when you do FOIL, the acronym for first, outside, inside, last, when you do the first two terms here, you only get a squared. So I know that this is what I'm trying to hope my answer comes out to be. When I do the second one and I multiply this by itself, 2a times 2a, that gives me the 4a squared. If you look at all these other ones, you know, even regardless of what comes after this, both of these two are going to give me 16a squareds. And I'm not looking for that. So I know right now the correct answer there is B. It might be worth kind of going over and reviewing how to square something. Just really quick, I'm going to kind of go and just look at one of these. A very common mistake when I see kids do this is they think that you can just square the first part and then square the second part. and they accidentally get the answer 4a squared plus 4b squared. But that's wrong. You know, you don't want to do that. How to do this thing correctly? 2a plus 2b times itself is basically, I need to do first times first, the outsides, okay, so that's 52, not 52, I thought that was a 6, it's actually a b. 2a times 2b would be 4ab. And then I do the insides, 2a times 2b, which gives me another 4ab. And then the last terms, which is 4b squared. And then typically you can combine like terms. You know, a lot of math is just doing a lot of problems and seeing patterns. That's how I kind of knew this AB was going to be in the middle. But just a little quick review there on expansion, or on multiplying two binomials is kind of the fancy term for it. All right, moving on to number 11. The volume of a right cylinder, so we have a geometry problem here. Just a quick reminder, you can go all the way back to the beginning and see your formulas. So the formula, if you don't have this one memorized, which it isn't critical, it could save you a little bit of time. But there's a right cylinder. So this is what we're probably going to be using, V equals pi r squared h. So you may have to fold back to the beginning of the test and come back to it, but that's okay, it only takes a second. So the volume of a right cylinder is 22 cubic centimeters. What is the volume of a right cylinder with twice the radius? So we got to have twice the original radius and then half the height. All right, so this is kind of a proportion problem. It combines volume with proportion. So the volume formula, pi r squared h, for the original one was 22. So this is for cylinder A. Now the idea is, what you want to do is you want to change the expression and you want to put twice the radius. So instead of squaring the radius, and remember this is just multiplied, this is just that times that times that. Instead of having r squared, we're now going to have twice the radius squared. Be careful that you put parentheses around that so that the 2 gets squared as well. And then half the height, so instead of h, you're going to have 1/2 of h. Pi is still going to be pi. And then the question is going to be, you know, hey, what does that come out to be? What's the answer? So the idea is, with these type of problems, is try to get some number in the front so you can see whether how much bigger or how much smaller it got. So let's kind of work this thing out. This is going to be pi times, well, 2r times 2r is 4r squared times 1/2 h. So now I'm just going to multiply these coefficients here. 4 times 1/2 is 2, and then pi, and then r squared, and then h. So now it's pretty easy to see the relationship. The first cylinder was just pi r squared h. The new cylinder is 2 pi r squared h. So basically we're just going to times this by 2, and we're going to get an answer of C, 44. But that strategy of translating these clues, whether they be percent increase, percent decrease, half, double, is getting the number out front is the most important thing that you need to do. All right, moving on to number 12. What to the following is equivalent to 9 to the 3/4 power? All right, so just a quick little thing when you're doing fractional exponents. One thing I always remember is, like, if I want to do the square root of 9, that can be rewritten as 9 to the 1/2 power. So basically there's a link between the 1/2 power and the square root. And how you kind of translate this is, the square root of 9, there's actually a 2 outside there that we normally don't write. That's the square root. If there was a 3 out there, it'd be the cube root. And then 9 is actually 9 to the 1st power. And that's kind of where this fraction comes from. So this top number here is on the inside power of your base, which the base in this problem is 9. And then the 2 is outside the radical, or outside the square root. So top's inside the radical, the bottom's the outside of the radical. So that there's a lot of things going on in this problem, but that's kind of a key basic fact that you need to have. All right, so let's get after this. Well, 9 to the 3/4 can be rewritten then as the the fourth root of 9 to the 3rd power. So I put the 3 inside, the 4 outside. I'm looking over here, and none of these options seem to have that in there. So there's more to this problem than that. So another thing you can do is if I can break the base up into another exponent, kind of like this 9 can be rewritten as 3 squared, because I see some 3's in here which are telling me maybe I need to do something with that. So 3 squared gives me 9. So there's 9 to the 3/4. And from your law of exponents, whenever you raise a power to the power, you pretty much just multiply the two exponents. So 2 times 3/4 is 3 to the 6/4, which reduces to 3 to the 3/2. So now I'm going to go and I'm actually going to use my rule. And I'm going to put my base of 3. I'm going to put my top number inside, my bottom number outside. So we're talking about the square root. And I look over and I still don't see it as an answer. But this is really just what is the square root of 3 to the 3rd power. 3 times 3 times 3 is 27. So now I'm going to try to simplify this square root of 27. And I believe I can break 27 up into the square root of 3 times the square root of 9. And luckily the square root of 9 just happens to be 3. So when I put these two back together here, I have 3 radical 3. There's a lot of different skills in this video, and if you want to kind of check out some of my other videos, you may want to look for one on simplifying radicals. All right, simplifying radicals is what I did in this step to get rid of the square root of 27. Another one you're going to want to look at is when you check out the law of exponents. The laws, because there's multiple laws, but the law of exponents showed me how to deal with this and how to know that a power times a power. And then you just have this whole thing up here about fractional exponents. So there was a lot of skills built into this problem. Correct answer, though, is D. All right, number 13 here. At a restaurant, N cups of tea are made by adding tea bags to hot water. If T equals N plus 2, how many additional tea bags are needed to make each additional cup? So I'm going to kind of write this thing out. T equals N plus 2. Let me see here. So N is the cups of tea. And T is tea bags. Can't keep a straight face here saying tea bags, but whatever. How many additional tea bags? So this is the actual question. How many additional ones are needed to make each additional cup of tea? Well, I'm just going to make a little table. All right. I'm going to just say, hey, cups of tea, and then the bags. So I don't know. I'm going to just pick a number. Let's say we want to make 3 cups of tea. So if I plug 3 into this equation, 3 plus 2, it takes 5 bags to make 3 cups of tea. Well, my question is how many additional bags are needed to make each additional cup? So let's do an additional cup. If I put 4 in there, well, I just get 6. So it kind of looks like for every single additional cup of tea, you got 1 additional tea bag. Correct answer is B. I think they try to trick you. They try to make you think that the 2 has something to do with this, but actually, you're really focusing on the slope. You know, this is a linear equation. We're interpreting a linear model. And the slope right there is telling me how many additional tea bags are going to end up there. Number 14, looks like we have a function here. It looks like it's exponential too. So f of x equals 2 to the x power plus 1. The function f is defined by the equation above, which defined as the graph of y equals negative f of x. All right, so this is basically what's known as a transformation. Transformations are like reflections, rotations, dilations, those type of things where you're shifting something around on the graph. One thing that you want to remember, you need to remember that if it's y equals f of negative x, okay, that is a reflection across the y-axis. So you're going to flip something across the y-axis. When the negative's out front, when it's y equals negative f of x, and the negative's out front, it's going to be a reflection across the x-axis. And this is just something that you need to kind of memorize. So we're dealing with this situation right here. So at the end of the day, we're going to be reflecting across this x-axis. All right, so that's the first thing. All right, so let's kind of go back and let's get into the actual equation itself. So I'm going to make a little table because I don't know exactly what that thing looks like. I mean, I kind of do, but I'm going to pretend that I don't. So we have 2 to the x power added to 1 equals f of x. And I'm kind of writing it backwards just because I want to make a table where I think it's going to be a little bit easier to see. Now looking at my graph, it looks like my graph, all of these only go from -3 to 3. So I kind of need to know what's going on at those spots. So let's just pick a few of them. Maybe let's put 0 in for x. So that's going to be 2 to the 0 power, which remember, anything to the 0 power is 1, plus 1 gives me an answer of 2. So I know that there's a point. Let me kind of resketch over here a little grid. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So I know that the point 0, 2 is definitely on the graph. Let's put another one in here. Let's put a point, let's put +1. So that would be 2 to the first power plus 1, which is 3. So I know 1, 3 is on the graph. So I'm going to put that up here. Let's go negative. So I do a -1. So 2 to the -1 power. Well, that's a whole separate animal on negative exponents. But really, 2 to the -1 power, you just make the power positive and put it underneath 1. So it's really 1/2. So 1/2 added to 1 is 1.5. So that gives me -1, 1.5. And I'll go one more in the negative direction. I think that'll be enough to see. So if I do -2, well, that's 2 to the -2 added to 1. So basically that's 1 over 2 to the +2, or 1/4 plus 1, which is 1 1/4. And so you start to kind of creep down closer and closer to 1. So our graph's actually looking something like this. So this is the original graph. Well, now, since this is what we're after, we need to reflect that across the x-axis. So every point is going to get flipped or reflected over that axis. So we're just going to translate these points. So if you're 2 up, you're 2 down. This point was 1, 3, so you're going to go 3 down. And we're going to have something that looks like that. So looking at my choices, my screen, I had to kind of blow it up, so I got to go down and look at the choices. But we're looking for something that matches, that goes through 2. So coming down, it looks like our match is going to be this one right here, because it goes through 2. This one's close, but the problem was it went through 1. So correct answer here is C. All right, number 15. Alan drives an average of 100 miles per week. His car can go 25 miles per gallon. Reduces gas by $5. Gas costs $4 a gallon. Which equation can be used to find how many fuel? There's a lot going on. A couple different ways you can solve this problem here. One is just kind of picking some numbers and doing some estimating. So let me try this. If he drives 100 miles per week, so he can go 100 miles in 1 week, and his car gets 25 miles for every 1 gallon of gas. Well, that right there can help me figure out how many gallons he uses. So if it's 25 miles for 1 gallon, it would be 100 miles, what he goes in a week, for 4 gallons. Okay, so I just kind of scaled it up a little bit. So I know that he's using 4 gallons per week. So he's using 4 gallons per week. And then we need to multiply that by the price of gas. So the price of gas is $4 per gallon. So it looks like this kid is spending 16 bucks a week, which is pretty cheap. All right. Now it says here he wants to reduce he wants to reduce his expenditure by $5. So when you want to reduce that by $5, so we're hoping to spend $11 in gas per week. So that's what we're trying to kind of figure out here. Well, let's just kind of do a little estimation. If I'm spending $16 and I want to reduce that down to $11, we're taking away $5. So $5 compared to 16 is about 1/3. About 1/3 of 16, roughly. So if we want to decrease our price by about 1/3, we need to decrease our miles. If we're doing 100 miles, what is 1/3 of 100 miles? Roughly, just ballpark it. You don't need to be exact here, but somewhere around 33 miles. So I know that we need to reduce our mileage by about 1/3, because that'll reduce our price by about 1/3. And this doesn't have to be perfect, because you'll see the numbers here. It becomes pretty obvious which one it is. So let's look at this 25 quarters. 25 quarters is really just 6.25, or somewhere around 6, let's say. So this one, 6.25. And then 4 over 25, well, that'd be 8 over 50. That'd be 16 over 100. So this is about 0.16. So a very small number. Well, we know that we need to reduce by somewhere around 33. So let's just plug 33 in and see which one of these makes sense. So in the first one, if I do 6.25 times 33 miles, that's going to be like $180, $190. So it can't be that one. If I do 6.25 times 33, it's definitely not going to be 5. Now, if I do 0.16 times 33, well, 0.16 times 33 is going to make it smaller, so it's definitely not going to be 95. And I think this one, 0.16 times 33, 16% of 33, 5, that sounds pretty good. So just using some estimation, I believe the correct answer is D. This other way I'm going to show you is probably faster, but it just may not be, you may not be able to grasp it, but I'm going to give it to you anyway. So if we go here and we look at this as a rate, and we say, hey, his car is getting 25 miles per gallon, and it's $4 per gallon. So his rate is, we're spending $4 for every 25 miles. Okay, because we get 25 miles to a gallon of gas. A gallon of gas costs $4. So our rate is $4 for every 25 miles. And if we times that by some number of miles, we want it to come out to be $5. Because when you cancel your units, you're going to be canceling out miles, and you end up with just dollars. So that one kind of checks out with this bottom equation. My rate of $4 per 25 miles times the number of miles. We're trying to figure out how we can get to $5. So the answer is D. It looks really easy, but to think in that terms, I think is a little harder. I know the first time I did it, I had to just run it with some numbers and see what shook out. All right, so as you can see, those last few started getting harder, 12, 13, 14, 15. It's always going to flow like that on the no calculator. 1 through 10 is going to be doable, and then all of a sudden you get to 11 through 15, and then you're in a dogfight. But now we get to go to the free response, which actually the free response is going to start over, and it's going to be a little bit easier. I mean, I'm not going to say easy, but easier as you kind of move. So if time is an issue, you may want to just jump right past 14 and 15 and jump right into the couple of the quick ones, because you'll see that they're not too bad. All right, let's take a look at number 16 here. Maria plans to rent a boat. Boat rental costs $60 per hour. She's also going to have to pay for a water safety course that costs $10. So you always want to kind of identify, this is a linear situation where you have some upfront cost that doesn't depend on the hours, and then you have a price per hour. It's almost like a slope intercept problem. But she wants to spend no more than $280. So if you want to set up an equation, it'd look like this. You say, well, it's going to be $60 times every hour plus $10 for the safety course. And we need that to be no more than, so we need that to be smaller than $280. And then I can just kind of solve this equation. Now it says if the boat rental is available only for a whole number of hours. So meaning like you can't have a fraction of an hour. What is the maximum number that we can rent the boat? So we're just going to solve this equation. This inequality symbol does nothing. You solve it exactly like you would an equal. Unless you divide or multiply by a negative, then you need to flip it. But I don't think that's going to happen here. So we take away 10 from both sides, and you get 60h has to be less than 270. Divide both sides by 60. And it looks like h is going to be less than 60 goes into there 4 times, which would be 240. And then with 30 left over, and 30 over 60 is another half. So about 4.5 hours. But it said we had to have a whole number of hours, so you don't want to round up to 5. The first whole number less than 4.5 would be 4. So the answer to this question is 4 hours. Now, if you don't like that inequality setup, which I get, you could also set up a table. So you could also kind of do a table, and you could say, hey, you know, here's hours, here's dollars, and let's just run this thing out and go for a little while. The only drawback to the table method is hopefully we don't have to go too far. So at your first hour, you rent it for 1 hour, so your cost is going to be $60 plus the 10 for the course, so you're up at 70. You know, if you go 2 hours, that's $120 plus 10 for the course. If you go 3 hours, that's 60 times 3, that's 180 plus the 10 for the course, which is 190. And you should see a pattern here. It's just going up every time by that $60. So if I continue the pattern and kind of cheat and just start filling in some numbers, go up by 60, go up by 60, and you'll find out that the 280 occurred somewhere in here somewhere. So you need to go down to 4 so you don't go over the 280. All right, number 17. Looks like we have what is the value of p, so we're solving. This is a linear equation. There are no exponents. So let's just solve a linear equation. I see parentheses. We're going to distribute 2p plus 2. Then I have 8p, and I got to be careful with the minus. That's minus 8 equals 5p. So the left-hand side needs to combine some like terms. I got 2p's, 8p's. We're looking at 10p's. I got positive 2, negative 8. That's a negative 6 equals 5p. Now I want to get all my p's to one side. So I'm going to, since I only have p's on the right, I'm going to subtract these 10p's. You don't have to do it this way, but I'm going to go ahead and do it that way. And I get negative 6 equals negative 5p. And then divide both sides. Divide by negative 5. Divide by negative 5. P equals. A negative divided by a negative is a positive. So correct answer here is 6 over 5. Since this is the no calculator section, they're not expecting you to mess around with decimals. Basically, you have 4 slots on the grid. You could either punch in 6/5, or you could punch in 6/5. You're actually going to be bubbling those. Or if you know 6/5 is 1.2, you could also put in 1.2. I'm sure they'd accept that as well. All right. What do we have next? We have number 18. So it looks like we have a system of equations. We also, I see, have some fractions here, so that's something we may have to deal with. But actually, so my strategy, I always have 2 ways. I either do elimination, which I have videos on that, or substitution. And I like to use substitution when you already have it isolated for a letter. It's y equals something. So I'm going to use substitution here. I'm going to basically take this 2x, and I'm going to replace or substitute that y there. So let's do this. 1/2 of 2x plus 2x equals 21/2. And this is 1/2 of 4x equals 21/2. Well, what's 1/2 of 4x? Well, half of 4x is just 2x equals 21/2. And then now I need to multiply, or actually I need to divide both sides by 2. So divide by 2, divide by 2, which is really 2 over 1. And whenever you divide fractions, you really just keep change flip. So you keep the first number the same, you change and you flip, and we get an answer of 21 over 4. So it says, what is the value of x? Looks like we just got the value of x. It's 21 over 4. So if you're thinking about how to put that in on the slots, you do 21/4. Now, do not get tempted to change that to 5 1/4. You know, I agree, 21/4 is 5 1/4, but there's no way to put the space in. So if you screw up in the 4 slots, you put 5 1/4, it thinks you mean 51/4, which is a totally different answer. So never do mixed numbers on the free response section. All right. Number 19. Let's see what we got here. So we have an expression. We have a couple of fractions. Expression above is equivalent to a over x plus 2 squared. A is positive, so that might be important here somewhere. So we're not allowed to have a negative number. Give myself some room. And this whole business right here, a lot of kids get hung up on this. This whole business right here just means I can't put 0 in there, because then I'm going to have 0 on the bottom, and you're not allowed to divide by 0. So this really isn't very important on this problem. This is pretty important though. Only pick a positive a. Well, let's kind of write this thing out. It says that this expression up here is equal to a over x plus 2 squared. So we need to figure out what's going to be the numerator there. Well, normally if I want to subtract 2 fractions, I have to get a common denominator, right? So let's just pretend this was like 2/3 minus 1/2. I can't do 2/3 minus 1/2 until I get both these bottom numbers to match up. I find a least common denominator, which in this case would be 6, all right? So I can multiply 2 by 3, and if I do it to the bottom, I have to do it to the top, and I would multiply both of these by 2. So I'm kind of going to do that same idea here. So let's kind of go like this. We have a 2x plus 6 over x plus 2 squared minus 2 over x plus 2. Well, to get those to match, you know, this x plus 2 squared here on the left, that's really just x plus 2 times itself. So I can kind of extend that bar. So to make the right side match, I got to do another x plus 2 times itself. And if I do it to the bottom, I have to do it to the top. So now I think I have something that kind of matches here. So once you have it lined up, you know, just like if I go up here and I finish this top part, that would be 4/6 minus 3/6. Now I can just do 4 minus 3, and the bottoms you keep the same. So I'm going to do that here. I'm going to do the top minus each other and keep the bottom the same. Now, to keep the bottom the same, it's just going to be x plus 2 times itself, but I'm going to write it like that so it kind of matches. But I could have wrote x plus 2 times x plus 2. Here's where the tricky part is. The tricky part is this top part. So this top part, I have a 2x plus 6 minus this expression, which that expression is 2x plus 4. Okay? So I have 2x plus 6 minus 2x plus 4, and be careful, this is where you got to remember that you have to distribute that negative 1. So I have 2x added to 6 minus 2x minus 4, and when I combine like terms here, the 2x minus 2x goes away, and the 6 take away 4 just comes out to be 2. So a in this equation shakes out to be 2. That was a tougher problem. All right, last one, number 20. Looks like I have some geometry. It doesn't look too crazy, but it's number 20, so that worries me a little bit. I have intersecting lines, R, S, and T. What is the value of x? So some things that you need to know here is that all triangles add up to 180 degrees. And another thing we need to know is if you form a straight line, so for instance you have two angles here, let's call one x and one y. Straight lines also, they're a half a circle, so they also have to add up to 180 degrees. Another thing you might need is that if your vertical angles, meaning like if this angle is worth x, you can jump across diagonally and that angle has to be worth x. They're called vertical angles. So let's see if we can use these facts here. So first thing I see is I'm going to use this 106 to make a straight line. It has to equal 180. So when I do 180 subtract 106, I get 74 degrees in that corner. And if you know the exterior angle theorem right now, you could actually use that. But I'm going to just kind of do it old school. So now I have this triangle that I want to focus on that needs to add up to 180. Well, right now I have 23 plus 74, which is 97. So I have 97. I need 180. So let's subtract and see what we have left here. It looks like we need 83 more degrees. So you're 83 degrees. And then now I can use a straight line to kind of jump back out because that x at 83 have to add up to 180. So 180 subtract 83. And you actually get 97 back. We kind of just undid what we did. So the answer to this question is 97 degrees. But just let me show you the exterior angle theorem because occasionally you might see that. So if we look at what was going on over there, I'm only taking part of the picture. Anytime you need to find this outside angle, this is called the exterior angle, that exterior angle is always going to be equal to the sum of the two far away ones. That's how much this guy is going to equal. So that's just a little shortcut. Might save you a step, save you a little bit of time. All right, so that was the no calculator. Now we're going to move on to the calculator section.